Hello friends, today we are going to look at one new problem. It's a very different kind of problem, linear programming. It's an advanced problem, right? So usually you'll find this subject in engineering. So let's take a look at it, how we can solve it. So here we are given that some company makes two products, tables and chairs, which must be processed through assembly and finishing department. Basically, there are two steps. First is assembly and then finishing. Assembly has 60 hours available per week. So in assembly, we have a maximum of 60 hours per week, and then in finishing, we have a maximum of 48 hours per week, right? And manufacturing one table requires 4 hours in assembly and 2 hours in finishing. And for each chair require 2 hours in assembly and 4 hours in finishing. If profit is P8 per table, actually this P8 is some printing error, so it will be basically 8 rupees or $8, whatever you may take, and the profit for per chair is 6, right? Only then, because if it's P8 or P6, some variables, then we cannot solve it, right? Then we will not be able to draw the lines, and will not be able to solve the equations. So it has to be some real value, 8 or 6. It's some printing error is there in the problem. So I'm just taking the profit per table to be 8 and profit per chair to be 6, which is good for understanding the concept basically. Right, our goal is to understand the concept, not to just get the answer, right? So the problem is to determine the best possible combination of tables and chairs to produce and sell in order to realize the maximum profit. Means how many tables should we produce and how many chairs should we produce within this given time period of assembly and finishing. Within all these constraints are given. Now how many tables should I produce, right? Let's say I'll produce T number of tables, and how many chairs should I produce so that I get the maximum profit, right? So this is the problem. So how can we solve it? Let's say we should produce T tables and C chairs to get the maximum profit. So what is the relationship between T and C? So first of all, it's given that in assembly, let's say the total time spent in assembly can be maximum 60 hours. So let's say so for total T number of tables, let's say the time spent is, so what will be the total time spent for T number of tables? 4T. And what will be the maximum time, total time spent for C chairs? It will be 2C, right? C chairs are there, so the total time will be 2C. So 4T plus 2C, it has to be less than or equal to 60, right? It's given that in assembly we can have maximum of 60 hours. So similarly for finishing, so one table takes 2 hours, so T tables will take 2T hours plus, and C chairs will take 4C hours, which will be less than or equal to 48. So these two constraints are there, right? And what we have to maximum? We have to maximize the profit. Profit per table is 8 and profit per chair is 6. So we have to maximize this value. So total profit on all the tables will be 8 into T, plus total profit on all the chairs will be 6 into C. So we have to maximize this value given these two constraints, and also not to mention T and C both are positive, right? They are greater than or equal to 0, right? Number of chairs and tables will be positive, it can never be negative. So we just write down that equation so that we are only working in the first quadrant of the graph, right, where both T and C are greater than 0. Now I have drawn these two lines. So so if we have to see 4t plus 2c equal to 60, let's look at this line, 4t plus 2c equal to 60. So if I put t is equal to 0, which means I am on the c axis, y axis or c axis. So if I put t is equal to 0, c will be 30. So this point is 0, 30. Similarly, if I put c is equal to 0, t will be 15. So if I put c is equal to 0, t will be 15. So this point is 15, 0, right? Similarly, for the other equation, which is 2t plus 4c equal to 48, or if we divide it by 2, t plus 2c equal to 24, right? So if we take c is equal to, if we put c is equal to 0 in this equation, t will be 24. C is 0, t is 24, right? And if we put t is equal to 0, c is equal to 0, so this point is basically 0, 12 actually, right? If we put t is equal to 0, then we'll get c as 12, and this point is where c is equal to 0. So and t will be 24. So this point is 24, 0. And this is another important point where both the lines meet. So how can we find out this point, the coordinates of this point? By solving these two equations, right? So let's solve them. So so basically we have to solve this one and with this one, right? This is the reduced form of the same equation. So if I subtract 2 from 1, 2c will get cancelled out, 4t minus t will be 3t equal to 60 minus 24 will be 36. So t will be equal to 12, right? If I put this t back to second equation, I will get 12 plus 2c equal to 24. So 2c will be equal to 12, c is equal to 6, right? So I got the coordinates of the point of intersection. Basically the solution of these two equations is the point of intersection where both of them are true, right? T is 12 and c is 6. So, and now let's look at the inequalities. So we have to work in this region, right? And t and c are greater than 0. So we are only working in this region. So we have this whole region. We have to find a point. Basically a point means a value of t and c, the number of tables and the number of chairs. We have to find that set, right? A particular value of t and c where we have to maximize this equation, at plus 6c, right? So when using the graphical method, the critical points are the 4 corner points, right? This point, this point, this. These are the 4 corner points where the chances of finding the maximum value of this equation are there. For any problem you are going to solve, these are the points to look for. So now let's put the different values. So we have what we finally got these values of, so we are working like this, t comma c, and this first corner is 0 comma 12, then the second corner is 15 comma 0, and the third one is 12 comma c no, comma 6. So most of the time either this will be the solution or this, like one of these three, right? But let's start with this 12 comma 6. It looks to be like most probably the solution, but let's just put those values. So for this, what we'll get, the answer will be 12 into 8. 12 into 8 is 96 plus 6, 6 into 6 36, which comes out to be 132, right? And if we take the second point, t is 15, so 15 into 8 is 120, and c is 0. So that's another value of the profit we are getting. Now if I put 12 into 6, that comes out to be 72. So the maximum profit is, if we produce 12 tables and 6 chairs, we get a maximum profit of 132. So in this way we can work out such problems, right, where multiple variables are involved and we have to find profit, or we have to maximize a certain parameter. So this is the way to go with these kind of problems. Thank you for watching. If you like, please share, subscribe, and share with your friends and everybody you think he will get value. Thank you so much. Any questions, please ask me.